Because next I want to welcome Vlasta Sikimic, who will be talking about values and automated grant review. Please welcome her here.
Thank you.
You're welcome.
Thank you all. This talk happened, I was invited to present here rather spontaneously, but the best things usually happen spontaneously. And I, as introduced, will discuss different values that influence potentially algorithmic grant review. Let's think about what is the challenge of the grant review. We are in this situation where we are wasting a lot of our research time writing different grant applications, but also from the perspective of the evaluators, most of us had the opportunity to evaluate certain grants, and there we notice this is really hard to predict whether a project will be successful. Here we even see the joke that for Sir Isaac Newton, maybe it would be difficult to fulfill current criteria of grant applications and grant review. The grant review is exceptionally important for several reasons, and these reasons are connected to the values of our society. The values that come into play are both economic values, then some epistemic values, meaning we want to learn from science, and in which way are we going to learn best. And we also have ethical values. So if some research might be exceptionally beneficial to learn about it, but it's still unethical, we will not fund it. Presumably, I mean, I hope so. And all those values are now assessed not only by peer reviewers, but also by the funding agencies, and the general public has a certain say in which projects should be funded and how the research should be steered. And this is one very complex intersection where we have the private and public funders, or also public funding of private projects and so on. In this setup, we are spending a lot of time on reviewing and deciding what to fund. And moreover, research is showing that there is a weak correlation between the project success and the scores that evaluators gave to these projects. That all raises questions. Can we do something better? And one approach that philosophers of science are exploring is the approach to just randomly assign funding for projects, so just to do lottery. The reason for that, there is an epistemic background for that, and it says, okay, when we want to increase diversity in science, presumably diversity is something good. Here we have a completely random procedure, non-biased one. Let's assign it by lottery. Of course, this is rather efficient, it's very quick. We just do it, it happens. On the other hand, there is certain randomness, right, in this process. And there are also the ways to defend from that. So people would say, let's have a certain threshold. Every project that passes this threshold then can get randomly assigned funding. But maybe we want to do something better, so to save time and to use algorithmic procedures for the grant review. Here, my background comes from philosophy of science, and here I will try to point out to you the reasons why sometimes maybe there is something to explore there, and more funding agencies are looking into this, but also to warn about all the ethical and epistemic dangers of going into this direction. Currently, AI is being used to find different peer reviewers. It is also used by certain teams, especially the big research teams, to structure the team. And we explored whether it can really be used to predict epistemic success. Epistemic success is how much we're going to learn from a certain scientific project. The key questions that we're going to address are the epistemic one, so the learning potential, how much can we learn about the project success using automated tools. This is in a way a practical question, but it is related to the values of what we are tracking and also to the fact that scientific success is very hard to predict. The second question will be ethical, so should we do it? The machine learning is a very fast and cheaper method than having all the human reviewers, and kind of how reliable can it be depends strongly on the data that we have at hand. And we know that data doesn't exist without the data curation. So every data is already in a way interpreted in a certain data set. This is particularly characteristic in science, where we want, for instance, to measure the influence of a certain previously conducted project based on the citation metrics. These citation metrics need to be interpreted within a field, the reference point, right? So citations will be, citation patterns will be different in philosophy and in physics. So there are already a lot of decisions that need to be made when the data about scientific projects is gathered. Plus, keep in mind, we are all the time talking about higher level decision making, right? So about steering the whole epistemic community in a certain direction. Together with my colleague from the University of Belgrade, Sandro Radovanovic, I conducted a research on the data from the high energy physics laboratory Fermilab. This is one of the most successful and the biggest contemporary high energy physics laboratories on their previous projects, and we tried to see whether we can algorithmically predict the success of a project. The results showed moderately high accuracy, and there are reasons why this happened, and also the skepticism why this might not happen in other fields. First of all, we used limited data as inputs and outputs, and that is always a problem. What we had at hand was a repository done by physicists themselves, in which they evaluated their research, their citations based on their own standards, classified them based on their own standards, plus as inputs we had team size, team composition, project duration, and so forth. It was shown that team size mattered, and that the number of teams mattered, because it's easier to juggle with fewer collaboration partners, and that we also found a certain epistemic threshold after which investing more money, but in the sense more years in a project, stopped being worth it. This worked for one reason that we think is there. That's because in physics, these citation patterns are relatively stable and reliable. Of course, they are not 100% stable and reliable. But if we are turning already to biology, we are in a completely different situation. We know that in biology, we have something called the replication crisis. This means that a lot of results cannot really be reproduced, and even some highly cited papers sometimes get retracted. That creates a much bigger problem to use any output of that sort for these purposes. Another thing that we noticed in the literature were attempts to take data from the funding agencies across all disciplines and try to predict efficiencies, which is clearly a problem because only comparable projects should be used. There you see that already before doing anything like that, you need a lot of human intervention. So you need to go through all the data to see which projects are comparable, what should we do, how should we do it. It is not automatized by itself. The second point is that outliers had to be removed from this data set because outliers were presenting a problem in the for the algorithm, and we know that it's much harder to algorithmically capture some unobservable variables, such as motivation of researchers or the team cohesion, which is something that we would ideally like in a project. Plus, we might like even higher values that would be more complex ones, that would be like how inclusive is the project, how many PhD students will finish, what is the gender balance on this project. So our motivation for funding is highly dependent on the values that we want to promote, and not only on these citation metrics. There a human plays a role. And we have a potential predictability of the results, and that means that someone just then structures the proposals and the research teams in such a way to pass the requirements and get funding. Of course, there are technical means to defend against this, but it's still a problem. So from the epistemic perspective to this question, can we do it? Potentially, to a certain extent, it might be useful. And we know, for instance, that Volkswagen Stiftung is exploring this idea to use it when awarding different grants. But we noticed that only similar experiments should be compared, because that could cause a huge injustice to some disciplines if everything would just be piled together. And we noticed that this field-wise organization of data repositories is super important. And constant reminder that academic progress is very difficult to predict. From the ethical perspective, we notice that someone might try to have adversarial behavior, so just to win against the system, and that biases that humans make might also, we are aware of this, right? Everyone in this room is aware of this, might be mirrored through the algorithms. Finally, what I think is a very big concern, this is the data privacy concern, because this could lead to certain profiling of researchers based on numerical parameters that could influence their future career. In this context, we could have a hybrid solution. We could keep a human in the loop. So a human could be used to assess certain aspects, such as the motivation of the team or the team cohesion. This could be used as one of the parameters, or we could limit the use of data mining just to pre-screening. But there is the third tendency, which is philosophically very interesting. And it tells us, I will critically reflect upon it, it tells us the idea, let's just see and try to learn what are the preferences of the reviewers. What are the preferences of the scientists, and then apply that. We were interested in this approach to compare it, whether it would match the other efficiency measures, and our assumption is that it won't, because humans are probably rather biased, but that's to be explored. However, some people are also researching the same, thinking that this could be a good solution. There, the idea would be that all of us kind of make decisions which project is better based on some structural parameters, or which structural parameters we prefer over the others, and then just implement that. So the idea is let's pool the public opinion, but in this sense the expert opinion, and this expert opinion, but a public one, should influence our theory. In the context, we don't really need philosophers of science or social studies of science to decide about our theory, but we just pull from people and freeze it in time, right? It's not dynamically updated. We already here, so here you see this triangle, how theory is interacting with data. In this, that's what I mentioned before, that all data is already, in a sense, curated, in a sense, already went through some theory. Right? And we also now here see this connection between the theory and the public opinion. So does it make sense that the theory is just constructed based on the majority view of the public? Let me remind you of the moral machine experiment. I assume that most of you are familiar with this, right? the experiment is designed to see whether to kind of pool the knowledge of the moral intuitions of people across countries regarding autonomous vehicles. And here on the picture you see that's from one of the scenarios where people were responding. The autonomous vehicle can either hit the passengers passing, crossing the street, or the people that are in the car are in grave danger, potentially die. And here the idea was, let's see how people create moral theories, right? Or let's see what is the majority view. And the results showed that in some situations, people reason based on utilitarian principle, which is a principle telling us let's save the largest number of people, sacrificing the minority, the smaller number. But when the questions become more complex, and that's whether one would save either children or elderly people, or whether they would save doctors, because doctors are presumably in some, I mean, I don't know, that the participants answered the doctors' lives are more valuable, also answered in a sense that they would rather save children than elderly people. We know from the perspective of moral theory that this is ageism and this is discrimination, so we find it rather problematic. And in that sense, in this picture, what happens nowadays is that the theory also influences the vox populi, and there is something to theory that's not necessarily in the public opinion, right? So the theory gets informed by the public opinion, but it's not reducible to it. And to illustrate this with the example of science, in the past, women were not allowed to study or do science, and that was both the theory and the common opinion. What changed? Theory first changed and influenced the common opinion. Also, the common opinion was changing through the industrial revolutions and so forth, and was influencing the theory. So both of these things were dynamically updating and changing each other. That's why we have a great danger if we cut this link and only go from the expert opinion frozen at one time point to theory, and without any normative framework that goes back. This means that we can be in a sort of a loop, in a bubble, and this analogous problem that you are seeing that could happen when we are deciding which research to fund can also be mirrored, for instance, in the evaluation of the education. And there we also insist to have certain normative framework. What is the goal of our education is not just defined by the popular opinion, but also by our theories of what is valuable for society, and also what will be valuable for society in the future. In this sense, the recommendation is that we have to monitor and update advanced digital solutions based on all of these free channels. So both from the perspective of the theory, from the perspective of the data and how the data is curated. And for that, we are looking at the dynamically updating of the general opinions, which hopefully, ideally, our society is going in some more conscious way in which takes care of more values and certain idea of a moral progress. Thus, to have advanced learning with AI in science, we need the cross-disciplinary collaborations that will engage with data-driven studies, but also have a strong normative philosophical framework, and then influence and advise policies.
Thank you very much. It's very interesting to hear how you combine the ethics and the machine learning, while most people say ethics is for human and let AI do the rest, the theoretical part. But I see that here you make a very nice combination, a very nice collaboration between those two. I'm wondering, are there any questions that you would like to ask about this topic? see a question there behind.
Thank you. Is it working? Yeah.
Yes.
From my experience, I heard of a case of a Nobel Prize laureate who couldn't get a European Research Council grant. In this context, how important is the research per se, and how important is the story that the research tells? Because sometimes these are two different stories. And I think there is also an ethical problem, as long as a bunch of some others. Thank you.
There are many examples of that sort, and also I will like to share with you another one of Harald Zurhausen, who had the Nobel Prize for discovering the vaccine against human papillomavirus, which causes cervix cancer, saving so many lives. And his research was initially dismissed because his collaboration teams, first of all, it was very novel, and that's why his community was skeptical. And the second aspect was a completely biased aspect, and that was their proficiency in English. So there we see a lot of injustices that can happen. For this purpose, we do have this value that we want inclusive science, and that we want to fund diverse research. And even then, we can still make mistakes. But this diversity has a value by itself, in my opinion, and that's also something I'm working on. So thank you so much for the question.
Thank you.
Are there any other questions? Oh, I see two more. Okay, let's do 3 questions this time. One here in front and one in the back.
Good afternoon. Thank you for your presentation. I had a question about the AI algorithms that you trained or used or investigated to see if a proposal would be interesting enough. As you mentioned, induction, deduction is often easy for AI algorithms. Did you see any examples of abduction-based AI algorithms that could reason if such a proposal would be interesting in the future?
I must say that I didn't, but I mean, it's something to think about. So thank you for this comment that I will share with my colleagues that are more experienced in the formal stuff. Thank you.
Thank you, Vlasta, for the interesting presentation. I had a question on, I mean, you're talking also about knowledge creation and creating certain awareness. How do you see the role of the university now and in the future, also given the ecosystem that we are part of currently? So how do you see that?
I guess that this question goes in the direction whether it will become redundant or what was the...
Well, that was not my intention, but how do you see the university's responsibility also maybe as a catalyzer or of this new ways of learning and
yes,
the
yes.
Vox Populi,
okay,
which should be integrated?
I think exactly that, thank you, now I got it. I think it's exactly about this too, that we have to teach people about the values and that we have to teach them to develop their skills, that they are being active. So children, but also other researchers and so on, it requires much more independence. It requires certain epistemic flexibility. So we have to teach them a lot of these epistemic skills. And in addition to that, we have to teach them also, of course, some ethical theories, but in a context that they can apply it in the situations that come ahead in this very dynamic societal changes. And there are certain attempts done in this direction to try to really build, and that's what we are also trying to work on, so to build the way how people should reason and how, like, to teach them that to be inclusive epistemically, to teach them to be open-minded. And that's a challenge for all of us, but I think something that's achievable. And yes, I assume the university hopefully will play a key role in this. Thanks.
Okay, thank you very much. Thank you also for all your answers. Thank you.